Hey, what's up, YouTube? How's it going? Another day practicing calculus. Today, I think that we're going to spend the entire stream on section 3 on delta epsilon proofs, which 3Mizzy had a funny comment that's rage bait, because everybody in the world calls them epsilon delta proofs. I don't know why Taalman chose delta epsilon. It's very strange. I think it's rage bait to get people to check out this book because it's a wonderful book and it's hard to get attention, when you're publishing a new calculus book. All right, so I am joined by my beautiful kitty cat, Luna. She's right over here, right off camera. I expect that she's going to be really cute today. I hope so. What's up? How's it going, geometry? What up, dude? Okay, so let's get back to it. So this is the Farewell Calculus tour that we're currently on. Farewell Calculus. For right now is not the time of my life where it seems like I should relearn all of calculus. And that's okay. That's totally okay. Because right now I want 1/3 of my time of these streams to be, practicing math that's going to make me a better school teacher, and then 2/3 of the time is math that is more for me, like a little bit more for me as a hobby, but also some teaching practice. So it still benefits me as a school teacher, but we've got high school, college, and graduate level math. So right now, this is the end of the week on college level math with calculus. Next week, I don't know what's going to happen, but we're going to switch over to graduate level math, and I don't know what that's going to be like. I'm really curious, because there's a lot of new people in the chat who are probably going to be confused, and that's okay. All right, so yesterday we did a fair number of problems. In Taalman, she has a really excellent organization, I think, in this book. So this is section 1.3, delta epsilon proofs. The bookmarks is optional, but I want to make sure everybody sees these. Everybody who's here in my stream, because these are very important. This is conceptual pure math calculus, begins with these proofs. So the book is very well organized in these little blocks. We've got thinking back, concepts, skills, applications, proofs, and then thinking forward. I believe that's all of the sections. Let me confirm that. Yeah, thinking back, concepts, skills, applications, proofs, and thinking forward. And what's cool is we have now hit one of each of those different types of problems. So the first problem that we're going to work is a thinking forward problem. So, Taalman 1.3 well, there's not a number for it, but 1.3 thinking forward number 1. Let's copy this. Hey, bro, Cydrus, thank you, dude. Yeah, this is now going to be a new thing, because I don't really want the old live streams to be visible to new people. These streams are not designed to be rewatched. If you're enjoying them and that's why you signed up, I'm going to take note of that, because the live stream VODs are confusing a lot of people about what should I be watching? Should I be watching the live stream? Should I be watching something else? Bro, thank you so much, Cydrus. Is there a certain type of problem or like a topic you'd like me to work a problem from today? Thank you, bro. Cydrus 2856. Let's go, dude. Thank you for becoming a channel member, dude. What's the level of limits you're going to explain? Today we are going to be working a delta or an epsilon delta. Taalman has gotten it in my mouth, and that's terrible. These are not delta epsilon proofs. These are epsilon delta proofs, like anyone else in the world ever calls them. Epsilon delta proofs. Very simple ones, but still. You want to see some linear algebra? I'll do a linear algebra problem for you, bro. Thank you. What is there a topic in linear algebra that you'd like to see? Here are the chapters from the book that I'm working. I'd be happy to grab one. Sorry. Oh, wait, a 12th grader? Yes. Yeah. A 12-year-old cannot. I do not want 12-year-olds in the chat. There's certain laws and things, and different countries have different regulations. Not dealing with that. 13 plus in the live streams. But yes, a 12th grader, yeah. That's like an 18-year-old, right? You're now watching my past linear algebra live streams. Okay. Using Fraleigh, heck yeah. Yeah, of course an 18-year-old can, yeah. And I think anybody can watch. Now, you may not understand everything. Next week, I'm going to be doing graduate level math that you probably won't understand, and that's okay. Okay, well, if you want to see like a random topic, Cydrus, if it's okay with you, I'd love to show you a vector space problem. Have you seen vector spaces yet? Vector spaces is really, to me, the heart of linear algebra, and this is what turned me on to becoming a math major. Okay, bro, thank you so much. Let's work. Have you seen vector spaces yet? I will go off topic. Like, the stream topic today is calculus, but if somebody signs up as a channel member, I will work any topic you want to see. Thank you. I really appreciate it. If you haven't seen this yet, I can... Ooh, you're only on the first chapter. Okay. Ooh, what do I show you? I would like to still show you vector spaces. Okay? If that's okay with you. Like, it's a little more abstract than the first chapter, but this is where linear algebra starts becoming really beautiful, and I can connect it to the first chapter. Like, I will try to explain vector spaces to you, assuming that you haven't seen them before. You will try your best. Calculus is fun. Doesn't matter if it's graduate level. Well, next week, like, actually, today might be the last day we do calculus. So I know that this is very confusing. I promise there is a structure, there is a method to the madness, and we'll understand it as we go. Okay, heck yeah. Yeah, you're okay with that, unless you wanted to go through limits today. I'm going to pause. If you want to see limits instead, I'll do it, but I would rather show you some math that you want to see. If you're working linear algebra, I'd love to work a linear algebra problem. And bro, you are going... You know what? I want to show you some linear algebra. Dude, thank you so much. Why isn't my pen working? Cydrus 2856. You are now permanently... Look at this. You're right in there. You're right in there with this linear algebra problem set. Thank you, bro. Let's do a little detour into vector spaces. I think it's nice to... Well... Yeah, we are today working calculus. But let's take a detour... thanks to Cydrus. for getting a new channel membership. Let's see. So I want to explain a little bit about the concept of a vector space. This is the heart of linear algebra. This is really where linear algebra becomes its own field. A vector space is any set V with two operations plus and multiplication. Any set V and a field F, where addition will take two vectors and give you a third vector. It'll give you a new vector. So if you have two vectors, you can add them together, and we usually write v1 plus v2 equals v3. This is like the standard way, but there's other cool weird scenarios. And then multiplication will take a field element and a vector and then map to a scalar multiple of that vector. So this is like in so for example, in vectors in like Rn, right, you can multiply a vector by a number, right? 2 times the vector 3, 4 is 6, 8, right? So here, your k is 2, and your vector is 3, 4, right? And we get the same thing with matrices or single numbers. In this book, usually V and K usually is Rn and R. Like, well, this is vectors. Really, let me fix that. Most often in this book, we are working over n by m matrices with real numbers. I'm sorry if this is like a little overkill right now, but I think that you might be able to be following me here. So, matrices and scalars. Let me know if I've totally lost you. Let me know if I've totally lost you. If so, I will... What will be the duration? Today I'm hanging out for 1, 2, maybe 3 hours. Hopefully 2. What's the point of members only stream when I can just copy the link and download it? Yeah, I mean, that's fine. You can. It's fine with me. But it's partly, like, memberships is partly to help support what I'm doing, if you can afford it. You know, I don't want anybody to be paying anything if you can't afford it, right? Like, I want to find ways that you all can help me try to make this a sustainable full thing. Yeah, so these are scalars, exactly. But there's other interesting vector spaces. Like your matrices can have complex numbers, and we can be working over complex scalars. And pretty much everything in linear algebra still works. Like matrices with complex numbers and complex scalars. You could also be working over square matrices. So not n by m, but mn. This symbol This means square matrices. We could also be working over invertible matrices. So this is invertible. Do you know what the word invertible means yet, Cydrus? It's okay if not. If not, then I'm going to move on. In either case, I should probably move on. Let's get back to the definition of a vector space. The definition of a vector space is a set V and a field. It's important that this one is a field, and I don't want to get too far into what that means, but field F or K, what did I use before? K is more common in algebra. Axler uses F, but I like K. With well-defined addition and scalar multiplication. Okay, now we need to satisfy 8 axioms. We have 4 addition axioms. A1, A2, A3, A4, and we have 4 scalar multiplication axioms. S1, S2, S3, and S4. Now, what are they? Both of them need to be associative. Okay, what does that mean? Let me show you A1 associative. This means that V plus W, TUVW, let's go, U plus V plus W, whatever objects these are, U, V, and W, like they're no longer matrices or vectors or specific things, but anything where our addition can be regrouped in this way that we're used to. S1 associativity says that I like K's and L's. KL times a vector has to be equal to K times LV. Okay? So on this one, on the left-hand side, your scalar, you have one scalar, KL, multiplied by the vector, and then on this one, V maps to LV maps to KLV, right? It's like 2 successive multiplications. So this is associativity. Okay, nothing too surprising. You could think about how that connects with what you've seen so far. On addition, you need to have the existence of, I'll write it in fancy symbols, there has to be a 0. Or in other words, additive identity. A2 identity. What does that mean? That means there exists some 0 in the vector space such that for all vectors, v plus 0 is v. Okay? So this acts just like what we've seen so far. There's always a 0 vector or a 0 matrix Okay, what else do we need? We need inverses. So additive inverses. For all v, there is a negative v such that v plus negative v equals 0. So we have subtraction, quote unquote. Like, there's always an additive inverse, and so far it's always the same as -1 times the matrix, or -1 times a vector. And then, what is the last one? Oh, we need commutativity. Commutativity. So, A4, commutativity. We need, for all vectors, v plus w equals w plus v. So commutativity is another requirement. For scalars, for scalar multiplication, we need associativity. What else do we need? I know S3 and S4 very quickly. What is S2? Why am I blanking right now? What is S2? I think it's the existence of a multiplicative identity. It must be. Yeah. So again, we have an identity. S2 identity. I don't really like this color scheme, but whatever. S2 identity means it's a scalar multiple identity. For all... Oh, well, oops. There exists some element 1 in the field. And in fact, because it's a field, there must be a 1 in the field. And it satisfies for the multiplicative identity in the field, it satisfies 1 times v equals v for all vectors. Okay? And then we have distribution, the distributive property with 2 vectors, and the distributive property with 2 scalars. Let's get those written down. S3 and S4. I'm just going to try to write these more quickly. S3, S4 are that if you have 1 field element and 2 vectors, that we can combine multiplication and addition in this way. KV plus KW, right? And then if we have K plus L times 1 vector, then similarly, this is K times the vector V plus L times the vector V. So a lot of books will really emphasize that these vectors are different objects, you know, with some kind of like arrow or something. Just remember that these are totally different objects, and so it's not obvious that multiplying with an addition is going to satisfy the same distributive property that the regular numbers have. Okay, invertible means the matrix has an inverse that exists. Yes, exactly. Oh, I forgot to put chat up on screen. Oh, why didn't... Yeah, that didn't work. That is outdated. Can I refresh? There we go. Oh, do you all prefer the vibes of the... Do you all prefer the Hawaii stuff? Because I'm down to just keep the Hawaii stuff if you prefer. What's up, Tamwa, dude? How are you? Okay, so these are the axioms or the definition of a vector space. Let's see. Can I... I'm going to work number 16 very quickly. Thank you, dude. Fraleigh 3116 asks us if the set... This is one of my favorite examples that I think of that's not matrices, not Euclidean vectors. Pn is the set of all polynomials with degree less than or equal to n degree less than or equal to n real coefficients and the zero polynomial. Yeah, he says along with the zero polynomial, but I think zero we typically just consider to be a polynomial. Anyway, so this is now the set of all polynomials with degree less than or equal to n with real coefficients. And the question is Pn, the set of polynomials, degree up to n, a vector space over the real numbers? Okay, so first is addition well defined? Yes. If you have any two polynomials of degree up to n, oops. And we add with another polynomial, degree up to n, if we add those two polynomials together, then we get another polynomial with degree less than or equal to n. Cool. So now this is again another nth degree polynomial. It's possible that that coefficients can be zero. So it's very important to say degree up to n. For example, x squared plus 2x plus 3 plus... first I'm going to give this kind of example. 4x squared plus 5x plus 6. These are two second degree polynomials, and this is 5x squared plus 7x plus 9. and this is a second degree polynomial, right? Alternatively, Luna, you're cute, but you're annoying. Also, x squared plus negative x squared is 0, but this is still degree less than 2. Like, we still say that this, or x squared plus negative x squared plus x or something, that is x, and it's still degree less than 2. So, yes. Addition is well defined, and it's, if you take two polynomials, you get another polynomial of the degree up to the original degree. Then the next question is multiplication of a field element and a polynomial to an nth degree polynomial well defined. And in this example, the field is the real numbers. Yes. A real number times a polynomial is equal to RAN x to the n plus ... RA1 x plus RA naught, right? And now this is like some new coefficients that are all real numbers. I think that the book is usually alternating R and S to be real numbers. Luna, calm down. Right? So now this is still an nth degree polynomial. So we have those two properties. And now we need to check A1, A2, A3, A4. A1 again is the... Do we have associativity? Yeah. You can convince yourself trying this that P1 plus P2, P3 does equal P1 plus P2 plus P3. And that's because of associativity of coefficients. Like, all the coefficients have additive associativity, because you add the corresponding coefficients, and then those are associative, and you get associativity. Then we need identities. 0 is the additive identity polynomial. For any polynomial, the 0 polynomial satisfies this. What else do we need? We need inverses. For any polynomial, negative p would be negative coefficients. You just take all the coefficients to be negative. And now this is itself a polynomial, and if you add that to any other one, then there's 0. And once more, commutativity. Yes, commutativity. Yes. Any two polynomials commute under addition because of the commutativity of the real numbers. We need to check S1, S2, S3, and S4, and I will let you treat this as an exercise if you want to work this one and see. So this is a rapid fire intro, I feel, to something that you've probably not seen before, but this is one of the, in my opinion, one of the most beautiful examples of a vector space, and it follows like all the same structure of the matrices that you're learning in chapter 1. It, like, all the same theory works, like, in this more abstract, different example of a polynomial space. It's examples just like this that turned me on to proof-based math and becoming interested in pure math. So it was a joy to share this one with you, Cydrus. Thank you for becoming a channel member, dude. If I don't know the theory very well, I probably won't solve these kind of problems. Yeah, but this was... Don't worry if you didn't completely follow this. Yes, you need to know the theory, but these kinds of problems will help you learn the theory, and we just jumped ahead 2 chapters. So if you're enjoying this, dude, this is some cool, interesting stuff. Like, it's a proof type of question. Please reply and help you. What's up? Purchase a membership from an account, but I forgot that mail and I deleted browsing data. Please help. My parents won't give me another membership. Okay, it's with the same name, and you also commented on a video in the number theory playlist. Okay, let's go, dude. Well, how... You forgot that mail and you deleted browsing data. Dang. Bro, that sucks. I can see if I can find the membership you're talking about. It's Divium. Well, thank you so much for becoming a channel member, man. Like, it really means so much to me. I appreciate it. Let me just check my members list. Where, yeah, I see you. Your Divium P6... Your Divium P6U. So let me put you on the thanks page, man. I really appreciate it. Bro. Divium P6U. That may help you get into that account. I don't know. And we just had Happy Abe join earlier. Bro, thank you so much, Happy Abe, as well. Divium, can I work a calculus problem for you? The cat is on the table. She will be hilarious. Yeah. We'll do game theory someday. So, yeah, but no promises. I don't know when. Whoa, bro, you got his account. Yeah, I found it. It's there. I do see that you have a channel membership. I don't know how to solve this. Like, yeah, Divium should have a green name. Everybody should recognize that. I don't know. I can't, like, reset your password for you or anything like that, but you could... I wonder if I can, like, cancel, like, disable your membership and then you can sign up for this one or something. I don't really know. Okay. I don't have access. I can't help you get access to the... I don't have a way that I can give you access to that. I would say you can... I mean, do you have the email that that's associated to? Because you can use the forgot password. Yeah, I mean, honestly, if you signed up for a channel membership on an account that's not yours, like on your parents' account or something, I don't know. You shouldn't do that, I guess. Yeah. When will you be live for the next calculus session? We're gonna get back to calculus. I don't know. Today may be the last calculus stream for a while, because it looks like I'm not going to be getting, that high school job I was shooting for. So I want to do abstract algebra because there's a lot of people interested in pure math right now. I think learning to write proofs is the focus that I should be starting, and like we should be like zoning in a little more on proofs. So yeah, we'll do some logic at some point. I will certainly introduce logic in, we will be doing logic in the basic math series. I imagine that it's not next week, but the week after. I think it'll be the week after that I want to do the logic stuff. Yeah, Olympiad problems someday. I mean, I can't really help with that right now. I'm not ready to work those kinds of problems. But you can ask them in the Discord. You can join the Discord, and there are definitely people in the Discord interested in working those kinds of problems. Discord.jcpractices.com. If anybody wants to join. Okay. Let's get back to calculus, though. She calls them delta epsilon limits. I'm going to call them epsilon delta proofs. Okay. This next problem is a thinking forward problem. Okay, it says, the first one says, we still do not have a way to calculate limits easily. We have to do a long proof using epsilons and deltas. We still do not have a way to calculate limits easily. In the following problems, you will develop rules for calculating limits of some very simple functions. Okay. You know what? I'm just going to copy this. Okay, so we still don't have a way to calculate limits easily, but we can develop some rules for calculating limits of some very simple functions. So part 1, or part A, explain why it makes intuitive sense that limit, basically it's saying prove that limit as x yeah, limit of x equals c as x tends to c for any real number c. So this is part one. Explain intuitively and how could I prove that? Intuitively, the function f of x equals x is smooth and equals c at any x equals c. More precisely, f of c equals c everywhere. Then c minus epsilon equal. So like a tiny bit to the left, like 0.0001 to the left is just 0.001 less in the y value. This may be already kind of jumping to the epsilon delta proof. So if I wanted to try to use more intuitive words for somebody who hasn't seen epsilon and delta before, so it is arbitrarily close to C for x near C. Right? Like, the value being arbitrarily close to C, like, the exact same x coordinate would equal the same function value. Here, I've already started, essentially, part 2. I think I've got the idea on the intuitive argument for this one. For part 2, I think we're going to take delta to be epsilon. Let epsilon be greater than 0. For any epsilon greater than 0, it can be infinitely, just like minuscule, like a grain of sand, that small, right? Let epsilon be greater than 0. Then we see that delta equal epsilon satisfies the epsilon delta definition. Let x be such that so x is not equal to c, which handles like the left hand, or like the first less than sign. And the absolute value of x minus c is less than delta, which then, therefore, x minus c is less than epsilon. I took delta to equal epsilon, And then, therefore, the function value minus the limit value is less than epsilon for any epsilon greater than 0, where f of x is x and L is C. Therefore, QED square. Yo, dude, thank you for becoming a channel member. Bro, thank you. Abba Skayed. Let me know how to pronounce your name if I got that wrong. Bro, thank you so much. Abba Skayed. Skayed. Dude, I appreciate it. Congo M, the member of the channel. Okay, what does that mean? Where's the cat? She's sleeping on my computer. It's warm and she loves that right now. Can you teach pure Euclidean geometry after this? No. No. I'm not. Oh, Kayed? Okay, nice. Thank you. Kayed. Dude, thank you. All right, well, I appreciate it. Can I work a calculus problem for you? Or also, Divium, is it okay if I'm going to give you credit for this calculus problem we just worked. Bro, thank you so much. Did I put it somewhere else already? I'm just going to call you Divium because it sounds like the last letters are randomized, right? And then, yeah, for Luna level, I'll be working a problem from the section I'm already working most of the time. Unless somebody asks for linear algebra. And then I might do linear algebra just because I want to. So let's do another calculus problem for Abba Skayed. Abbas Kayed, right? Okay, thank you, man. Abbas Kayed. Or I could just call you Kayed if that's what you meant to say. How's it going, Gerson Franklin? How are you? What's up, everybody? Thank you again, y'all, for helping support my journey. We got these channel members supporting calculus so far. You are permanently in my book. Name is too difficult. Barely anyone can spell it. I try my best. I think it's important, to try, you know? Okay, so now I've officially done another epsilon delta proof. Okay. The next one's a little trickier. I don't know if I want to do that one yet. Yeah, we could do it. We could try it. I'm going to give you... Let's try to work this next one. Thinking forward number 2. So we have successfully done this first one. Now, explain why it makes intuitive sense that limit is x to... So this, we want to just snag this, if I can. Again, f of x equals... How do I... It has no jumps. This is my intuitive argument. I think we got the intuitive argument on this one. No, I'm not going to do a differential equation. We're not working on differential equations. Formally, let epsilon be greater than 0. We aim to find a delta greater than 0 such that for all x where x minus c, for all x not equal to c, and within a delta neighborhood, a punctured delta interval around c, then the function value is near L. And in this problem, x squared minus c squared is less than epsilon. So now we begin some scratch work. If x squared minus c squared is less than epsilon, then the absolute value of x plus c times x minus c is less than epsilon. I see that difference of squares, which is usually a pretty good sign, and I see that x minus c is right here, which is something we want to get right there, right? So I think that we're close. I will purchase membership again from this account. Dude, I appreciate it, but you don't have to. Like, can you cancel the other membership? Otherwise, you'd have 2 recurring payments. Also, anybody who wants to sign up for a membership, definitely do it from the website or an Android app. Don't do it from the iPhone app, because with the iPhone app, Apple takes an extra cut and it's more expensive, which is a bummer. So, okay. So I think that we're getting somewhere here. How do we do this again? I think we need to use this lovely inequality called the Cauchy-Schwarz inequality. That, I believe, is right. Bro, I don't know how I will look into this. I hope that I can cancel your membership on your behalf. I've never had to deal with this before. Yo, we got another hobbyist. Arlene, are you here? Dude, I can't believe you all. Thank you so much. Okay, I want to make sure I don't forget about this because this is important. So, Divium, let me try. I'll reach out to customer service if I need to. Yeah, I'll figure it out. I will figure something out. Hey, no way. Your grade 11 brother a great deal. That's awesome. I'm happy to hear that. I'm happy to hear that your brother is enjoying the videos. That really means a lot. Okay, Divium, I'm trying to make sure I remember to delete this stuff. Okay, so let's see. I mean, the problem did say, hint, assume delta is less than or equal to 1. So, let's see. The problem did give this hint, and I want to remember that. I just want to see if I can find that point myself, but let's see. I do remember that it gave that hint, and I haven't yet assumed the hint. I want to see if I can figure out that hint on my own. So, absolute value of x plus c, x minus c has to be less than or equal to the absolute value of x plus c times x minus c. And if we assumed Hmm. I don't know if that works. But yeah, let's just try to take the hint. So let epsilon be greater than 0. And assume delta is less than 1. Let's just see if we can find... Then... if x is not c and close to... is close to but not equal to c, first off, x is not c, and x minus c is less than delta, which is less than 1. Consider... or... then f of x minus L is x squared minus c squared, which is x plus c times x minus c. And absolute value of x minus c is greater than 0 and less than 1. So, because, oops. Yeah, I mean, how do we get our epsilon here? How does this work, man? Like, I'm so weak. I'm so rusty on my epsilon delta proofs. I feel like I've got something along the right idea by using the Cauchy-Schwarz inequality. An absolute value of x minus c is less than 1. Oh, I feel like I'm so close. My chat is behind, isn't it? Why is my chat behind? We have absolute value x minus c is less than 1. Okay. Okay. Yeah. Let's see that. So, absolute value of x minus c is between 0 and 1. Which tells us that negative 1 is less than x minus c, which is less than positive 1. Is it something like this? Wait. Remove 0. Don't remove absolute 0. That's what makes it work. We can add c to all parts of the equality. That's what I did in the second line there, right? Wait. Don't remove 0. Didn't I remove 0? Well, oh yeah. The 0 part of this doesn't lead to the next line. It doesn't hurt. It doesn't make it false, but the next line is equivalent to the previous one, right? That bounds x plus c. If I add 2c to the whole thing, yeah, okay. So then x plus 2 or x. Okay. Okay. Yeah. X plus c is then... So I need to add 2c to both sides of the inequality, right? In order to bound that, but... Or is it... Yeah, doesn't this say that x plus c is less than... How do these freaking work, man? Yeah, it seems like a triangle like I was thinking of triangle inequality. Absolute value of x minus c can be as little as you want to, and x plus c is bounded in x. So yeah, that's what I was. That's what I thought I was showing before, over here. Like x plus, like by Cauchy-Schwarz, we get that third line in this. And then because we have a bound on x minus c, then we have this. And then I can maybe do a triangle inequality on this. How do we get to epsilon, though? Like, we need to define epsilon without depending on x. I feel like we want to make some kind of assumption that delta squared is less than epsilon squared or something. Because like we haven't written down delta in terms of epsilon anywhere. So that feels a little funny. Oh wait, no, we want to write. Can we just take delta to be epsilon? I think we would expect that in this kind of problem. Yeah, I think we would expect delta to be epsilon and for it to be between 0 and 1. Now we have an epsilon in this thing, right? Because epsilon is equal to delta. So that thing is, this line is less than delta, which is equal to epsilon. And I believe that, oh, and this is less than epsilon because delta is less than 1. So I think that we know that the absolute value of x plus c needs to be less than 1 as well. Like, because we're taking, because x is in c minus delta to c union c to c plus delta. So Um, and this is a subset of C minus 1, a proper subset of C minus 1 to C union C, C plus 1. So I just feel like I'm missing, like, I think I see why absolute value of x plus c must be less than 1, which would then complete this, but I'm having a hard time writing that down. But I see that it's, like, in this delta neighborhood. Man. Yeah, we should get delta in terms of epsilon, right? Yeah, divium, exactly. So this is the more formal pure math version of the definition of limits. This is like the pure math version. It's harder. So I think taking delta to equal epsilon should work for this. Kind of problem. New page. Let epsilon be greater than 0. And in other words, if we want it to be less than or equal to 1, we need it to be the minimum of 1 and epsilon, right? So delta is less than or equal to 1, guaranteed. Which is less than or equal to epsilon. Then assume Oh, wait. Oh, x minus c is strictly less than delta. So then x minus c is strictly less. There we go. Okay, I was like, something feels very wrong here. Strictly less than 1, which is less than or equal to epsilon. Wait. No, epsilon can be less than 1. What am I talking about? No, yeah, this is false. This is false. That line is not real. But we do know for sure that delta is less than or equal to 1. Delta is bounded above by 1. Can we try triangle inequality at the beginning? Like, it just sounds like a Cauchy-Schwarz, since this is like a product, like a difference of squares, but I mean, we could try this. I don't think triangle inequality is the way. I don't feel like that's the way. This gets us our beautiful x minus c and x plus c. By Cauchy-Schwarz, this is this. X minus c is less than 1. So then this x minus c, so now we know that this is strictly less than, it's greater than 0 and less than 1. So we have that. Any hints? Man, I feel like we're so close. Dude, Lockheed, what's up, man? Epsilon is arbitrarily small and you don't choose it. Well, no, you fix an arbitrarily small epsilon. Like, you let epsilon be greater than 0, and then you define delta in terms of epsilon. So on this, I define delta as the minimum of 1 and epsilon. If epsilon we chose to be 10, then delta is 1. But if epsilon is less than 1, we choose epsilon. Right? What's up, Lockheed? Lock, we are working this problem. I'm trying to do a delta epsilon for limit of x squared equals c squared. I can write it here. We are trying to triangle to get this one. My analysis is so bad. But that's why we're here. That's why we're practicing. And I'm trying to get back to it. Thank you, Crimson Gamer, bro. Thank you so much. I'm glad you're liking my videos. Human joins Math Live. Human sees real analysis. Human scared. Right? Benjamin, that's how I feel, dude. That's how I feel. Ask Claude. I'm tempted. Delta epsilon still trips me up. Me too. Why would we ever call it delta epsilon? It's epsilon delta. My chat keeps falling behind. Oh, Sumit Sharma, did you sign up as a... Oh, wait, no, never mind. Okay. Dude, I swear we are close. I was thinking of trying to do something like... Well, wait, delta being the square root of epsilon? I mean, then delta's going to be bigger than epsilon. Right? Use triangle and substitute the assumption. Yeah, I was thinking that we might do a triangle. Can we do something like x minus c plus 2c? This, now we've landed in some weird other... No, I don't think that this works, does it? I don't think that this gets us anywhere. But we do have x minus c is less than 1. Strictly less than 1. We want to get back to our epsilon. I mean, like here we do have that this is less than epsilon. But now we're not going to get to something that's less than epsilon. We're always adding positive amounts. So that gets us stuck. So I feel using a triangle inequality by rewriting x plus c as x minus c doesn't work. I don't think we can get anything with this, can we? There is like a reverse triangle inequality, but I think it reverses in the other direction. Um, hmm. I know somebody's figured this out. X minus E mod less than delta, then combine these two steps, bro, and you're done. So I'm close, right? Like, yeah, I don't understand the Hindi conversation, so Locke, you need to let me know. I don't think delta greater than epsilon should break anything. Maybe not. But I just don't see why bringing in a square is going to help. I just don't follow what you're saying here. X minus C, what do you mean mod? Mod less than epsilon divided by C mod C plus 1. Are you saying is less than? You know what you should do? Draw a graph. I feel I should draw a graph. I don't know what spammers you all are talking about. I'm not seeing... Oh, I'm not seeing everything. You all are seeing more than I am. I only see top chat. If I look at live chat, there's like a lot more spam going on. Yeah, Lockheed. If there's spam that you're seeing, please feel free to time out people. I don't know if it's... This language is Hindi and they're doing rubbish talks here. People are allowed to speak Hindi in my chat. I'm okay with that, but not if it's off topic and if it's spam, if it's anything hateful, if it's anything inappropriate. So Locke, I'm going to leave that decision to you. You can use the timeout feature. You could time somebody out for 10 minutes, time them out for 5 minutes, you know, time them out for 24 hours, whatever he feels right. Like, Hindi is fine in my opinion, but not something inappropriate. So, like, how do I know? My eraser has gotten too small. Okay. Okay, so you're saying x minus c less than epsilon divided by 1 plus 2 absolute value of c? How would you know that? Like, we don't know that c is... We don't know where c is. C can be a positive number. C can be 1,000,000. Right? Or C could be really tiny, like 0.00001. Oh, wait. Oh, then, but no matter what, we're still dividing and getting a... Okay, yeah. I mean, this would be true. Yeah, this would be true. I see that. But how did you get there? How did you find that also? Like, okay, x minus c is less than delta, which is less than or equal to epsilon. Therefore, x minus c is less than epsilon, which is less than... Oh, wait. Just because x minus... Because x is near c within epsilon precision. I mean, like, this one is much smaller, potentially. It should be sandwiched in between these two, right? So my assumption that it's less than delta only tells me that it's less than epsilon, not less than the smaller thing that you just told me. My internet doesn't want to let me help Rip. Okay, I don't mind if you all talk with each other and ask what you're eating. That's fine with me. Just ignore it, I guess. But if there's not a mod who speaks Hindi in the chat, then I'm gonna ask that you all keep it unrelated. I mean, yeah, Locke. I feel this is a decision point for, you know, for us. Like, do we allow off-topic conversation? I mean, Locke is a mod, you know, and it matters, I guess, what kind of design we want of the chat. That's okay with me. If it's just, if y'all are talking about what you're eating, that's okay with me. But yeah, all right. So okay, stream is fine. I'm gonna just walk and grab some water real quick and come back. I could ask Gemini, but that's lame, man. That's so lame. This is just one of those places where I'm like, well, I'm like kind of stuck. I want to just like pace, go grab a glass of water, come back, and then it might come back to me. Like sometimes you just get kind of stuck, and then you're like, I need to reset, like get some fresh eyes, just go for a brief little walk. Right, one in place of epsilon. But there's no epsilon right now. Like, be right back. Yeah, be right back. In the inequality, well, I don't have... Like, we're trying to prove that this thing is less than epsilon. I don't think that follows. Cyber. I think that was Leo Lectures. Leo Lectures recommended that one to you, Cyber. Or Potato. I should call you Potato, not Cyber. Okay, thanks everybody. I'm going to be right back. Here is some classical guitar recording that I recorded a little while ago. I hope you enjoy it. Be right back. Hey, let's get back to it. Sorry about the lag. It looks like my computer ran out of space, and yeah, apologies for the ad. We got to start running ads. Thanks for watching. Let's get back to this. So, I am trying to finish this delta epsilon proof, epsilon delta proof. Levi, how do you feel about your epsilon delta proofs? I'm so not great at them, man. Like, I'm just so not great. We're trying to prove... Oops. We are trying to prove that the limit of x squared is c squared as x tends to c. And from here, we define an epsilon neighborhood. Which then gives us, it should be more like this, shouldn't it? Yellow line up here for epsilon. Blue line's down here for delta. I mean, I really think that we can take delta to be epsilon. And it should work. But in the proof, we can also bound it by 1. So delta must be either epsilon or 1. If epsilon is bigger than 1, then, well, yeah. Nice. Okay, you didn't get an ad. Great. I think that we still get... Oh, you don't think delta equal epsilon would work? Is this one of these where I should just say, like, magically, like, take delta to be the minimum of 1 and, like, something like epsilon over 2? Like, split epsilon by 2, just magically? I mean, wouldn't this guarantee it? Like, it's just that the shapes... Like... Drawing the graph, I feel like that distance matches this distance. But maybe that's just in this example. Let's make this a much more extreme example. So, if we take a point where it's growing much more rapidly. Yeah, I think you're right. Yeah, that delta equal epsilon, I think, won't work. You're right. If this is growing much more rapidly over here, I mean, that's an extreme, but still, up here, say that this is the x value c, and then this is the function value c squared. And let's say that I took epsilon to be 1. So it's not like a tiny, tiny, tiny neighborhood. It's a relatively, actually large neighborhood around. Then delta must be much smaller than 1. You're right. Yep. I mean, these are not to scale, but yeah, you're right. Delta must be quite a bit smaller than epsilon. Yeah, the hand-drawn graph in that first example was a bad spot, but now this one demonstrates much more clearly. Because I picked a place that was where the slope was similar to y equal x, right? The tangent line was similar to y equals x, I think. No, that's not the point. My graph is... The point is that this is the graph of f of x equal x squared. Copy. So, in the epsilon delta definition of the limit, for all x in the delta neighborhood, then the function value is extremely close to the limit value. So the blue line is this, the blue lines are this delta neighborhood. And then every point within that blue rectangle, like for every point, for every x value in this little blue rectangle, the y values are within our tolerance, our allowed tolerance. So like c squared plus epsilon, and c squared minus epsilon. That's what I mean by a epsilon neighborhood. So it's similar to L. In other words, it's in the epsilon neighborhood. Yeah, the expression for delta should be obvious, and we're all just not finding it somehow. Well, I feel like delta is, I think delta is maybe epsilon squared, because if delta equals epsilon, and epsilon is small, then epsilon squared is going to be smaller, right? And, of course, 1 is equal to 1 squared, so maybe this is easier to think of. Right? 1 divided by square root of epsilon. My guess is epsilon squared would be simpler to try. Like, that's my favorite way to make a small thing smaller. Like, square it. And yeah, minimum of epsilon and 1 is epsilon, and then that fails. Epsilon squared is only smaller than epsilon if epsilon is less than 1. Yeah, but if epsilon is... Oh, wait, shoot. No, here I did take epsilon greater than 1. Oh... I mean, that's where I thought that, yeah, that's not going to work, is it? That's just not going to work either. If epsilon is 1,000, if epsilon is, like, huge, and C is sufficiently far to the right, then delta being 1 doesn't guarantee... Well, wait. Yeah, if C is sufficiently far to the right, then delta being 1 doesn't guarantee that the Y values are within the epsilon neighborhood, right? The original question said, yeah, gave the hint to assume delta is less than or equal to 1. That's what I'm doing here. That is exactly what this minimum does. This allows us to assume that delta is less than or equal to 1. So I've found like a concrete way to make that assumption. Like, I can't just assume it without defining it. Like, finding a way to... Hey, take care, Levi. Good to see you, man. Good to see you. Oh, Levi, if you don't mind, I'm going to write your name, by the way, in this thanks page. Maybe I did that yesterday already. Thanks, man. Thank you for helping us get here, you know? So if anybody signs up as a channel member, you get your name in the thanks page. Or even Super Chat. Super Chats also get your name in the thanks page. Any amount. I'm just like, I suck at analysis. I've always just, it seems like magic. Like, once, like, you need to have some clever idea of what to set your epsilon as. So usually you do these by working some scratch work. I should really have that one guy on. There's that struggling grad student. Man, I would love to have struggling grad student on stream to help me with these problems, because he's like really good at analysis. He's just like a nice guy, like from what I can tell. He just seems like a super nice guy. Anybody out there watch him? Struggling Grad Student is really good. YouTuber. He's not a streamer, but he posts videos. Would love to have him on as a guest. I wanted some teacher who would teach me good quality problems like every topic, but I found no one. In high school, teachers used to spoon feed me. And you're also DVM. All right, good to see you again. You should, just get to the one account that has the channel membership. Okay, so often you do scratch work first. So the scratch work is that we want x squared minus c squared less than epsilon. Then man, I just keep coming to this. I keep coming to this feeling. Oh, wait. If that is less than epsilon, we don't know that. I can't split it as a Cauchy-Schwarz inequality because you used to watch Struggling Grad Student. He was great. I just didn't follow your argument. I'm sorry. I just did not follow it. Get some values. That could be a way to find some pattern. Okay. We need xc epsilon x squared delta f of f of c minus delta and f of plus and minus delta. Let's just find both of those values. Dude, there's so many different values to be considering, right? I guess it doesn't matter what x is, but if c, like the extreme examples are going to be far from the zero, from the origin, right? So if c is 100, we want to show that the limit is 100 squared. Take epsilon to be, I think we still want epsilon to be small. Let's take epsilon to be 1 so that we can assume delta is less than or equal to 1. Then c squared or x squared, well, c squared is 10,000. If we take delta, if we took delta to be 1, then this would be 99 squared and 101 squared. 99 squared. We can do that. 99 squared is 100 minus 1 squared is 1, 2, 3, 4 minus 200 plus 1 is 9,801. 9,801. Right? 101 squared is 100 plus 1 squared is 1, 2, 3, 4 plus 200 plus 1. 1,000 or 10,201. Right? So if x, yeah, like clearly this ranges outside of that epsilon neighborhood that we want. We want the epsilon neighborhood to be 1, and so it fails. So we need delta to be much smaller. I think that this extreme example is working. Here. It's fine. We'll do both of them like this. Okay, so I like this extreme example that we have. The thing we need to tweak is delta. Just out of curiosity, what if we took delta to be 1/2? How much does that help? 99.5 squared and 100.5 squared. I don't feel like doing our, magic formulas, so let's just do 99.5 squared is 9,920.25. So we got almost 100 closer. And 100.5 squared is, yeah, so we're getting much closer this way. I can't choose delta in terms of C, can I? Am I allowed to choose delta in terms of C? Why do I feel, 1/2 is still too big. I figured it would be. But we see that we got a lot closer. We split the gap in half almost, right? So my point right now is that I'm expecting to prove to myself delta equal 1 fails. I was fully expecting that was going to fail. I wanted to see how much it fails, and then how much do we need to adjust from there. Like from the graph that I drew before, I convinced myself that for sure, I wasn't thinking that was going to work. I wanted to see this fixing, right? We're going to keep this extreme example. Am I allowed to choose delta in terms of C? Is your number theory playlist enough for problem solving basics? None of those are designed to learn from. So I wouldn't recommend it. I want to make that really clear. They're very unstructured. I am hanging out, practicing, trying to teach out loud, but they are not a course. None of those are courses. So watch out. Watch out for that. Am I allowed to... Dude, I don't know if this is cheating, but I should just look at the book before I ask the stupid AI. like, I have a quick question. Like, am I allowed to choose C in my... Am I allowed to use C in my definition of delta? Because then I think that I could get something that works. Do we have any examples in the book? I don't remember ever defining delta in terms of C, so I don't think so. So how can I figure out... Yeah, that's why I'm thinking, like, wait a minute. C is a fixed number throughout the entire proof, right? Like, if... That's my thought, too. Like... I'm mixing all sorts of things right now. Oops. Right. I think we can. Because it feels like I would need to choose delta in terms of C here. So what happens if I use 1 over 100? Times epsilon. Because epsilon is... Oh, shoot, wait. Here, first, yeah, I think I can formalize that, but if I choose delta to be 1 over 100, then f of 100 minus 100th and f of 100 plus 100th is 99.99 squared, and 100 plus 100th squared, which is We're getting closer. We're getting so much closer, but it's still not right. 9,998.0001. So we're still outside of the epsilon neighborhood, but we're getting really, really close. Can I always just take half? Just also take a half here? So what I'm suspecting, this is really gnarly, but I'm thinking delta is 1 over 2c minimum of 1 and epsilon. I just feel like this problem is not expecting something as crazy as this. It seems like a little... Yeah, exactly. See, right? Hey, thanks, dude. Charizard Pandy. There's somebody else in the Discord who's a Charmander, so y'all have to meet. If you just watch to get an idea and then read the book yourself, will I be able to understand? That's the goal. But the main series that everybody's subscribing for, and that I'm getting a lot of attention for, the main series is I am making lecture videos out of this book. So for what value of x does f of x equal c squared minus epsilon? Between that x and c. Y'all see why, I always thought that analysis would just kick my ass in grad school. I don't know why. I've never been able to really do great at analysis proofs. These things are just magical to me. I think that this one works. Plus 1 over... Let's see, wait. Yeah. This one works. So it is within 1 unit. I chose epsilon to equal 1. Right? So now finally we have found one neighborhood. Here, wait. I know how to do this. Cut this one. Move this one. I want it to match the others. Minus is above, plus is below. So now we found one that works. I'm using my handy dandy calculator. 1/200 did not work. 1/300 did work. 1/250 does work, I think. Yeah, 1/250 does work. 1/275, we're doing a binary search. 1/275 works. 1/285 works below. 1/290 works below. 1/295 works below. 1/299 works below. Wait. Oh, wait. Oh, I'm going the wrong direction. Wait. 250 works. 200 does... Oh, wait. 1/200 does work. Shoot. Oh, no. 1/200 works. Okay, cool. Here's some neat little data. This is a really interesting point. This is valuable even if it's not going to yield a proof. I still think that this is valuable to build up some intuition on this thing. Shoot. Okay. One over 200 is really interesting because f of 100 plus 1/200 in other words, that squared one of them works, one of them doesn't, and I've already forgotten. I think yeah, minus works. It's above that. Yeah, it's... How do I present it? 1, 2, 3, 4. 1, 2, 3, 4, 2, 5. So this one is within 1 unit of 10,000. So it works. But then the other one does not. 1, 2, 3, 4. Point 1, 2, 3, 4, 2, 5. 1, 2, 3, 4, 2, 5. This one does not work. So delta needs to be smaller than 1/200, which is now depending on the value of C. I believe, and now I'm just going to check 1/250 works above, and we assume, like, since the previous one worked below, then all of these are going to work below. So 1 over 200 failed above, 1 over 250 works. Oh, wait, no. 1 over 200 failed above. 1 over 250 works above. So what about 1 over 270? Oh, wait, no, 225. I'm trying a binary search here. 1 over 225. And we're checking above. Yeah, this one works. I just want to see if I can find the point, like with a little more accuracy. When does this flip? I don't think I need any of this anymore. In other words, I'm saying that my test that I'm testing is f of c plus delta is less than L plus epsilon. Specifically, in this example that we're working, 100 plus delta squared less than 10,001. This is the test that I'm running right now and trying to find a point when it fails. So halfway approximately between 200 and 225 is 212. At this point, I'm just super curious. I don't know if there's a way that this is going to yield an answer. This one also works. This one also works. This one also works. And this one also works. This one also works. I think we've got 1 over 2c. Yeah, this one also works. It looks like we're going to be going for, everything. Let's see. I can just throw some zeros at this thing. Oh, no. If I throw zeros at it, we do get it to fail eventually. Which is interesting. I got this one to fail. 0.001. This one fails. Unless it is some kind of like rounding error. Unless it's some kind of rounding error, I'm getting 10,001 plus a small. I mean, I don't think that this would be something that the computer would fail at. That's interesting. If I take away 1, 0, it works. We went into binary search mode here. We went into gather some data and find a point when true flips to false. And we finally found a place where it fails. So what about right in between the two? In between the two works. What if I split the difference between those? That one works. Did I get this wrong? Wait, 001. Did I get something wrong here? 001 fails. 001 fails, 002 fails, 003 fails, 004 fails, 005 passes. And then anything above 005 passes. So I went the wrong direction on this one. I saw 1/200.004 fails. 1/200.0045 fails. One over 200 for 9 fails. If I keep adding 9s, it takes a bunch of 9s until we finally get it to pass, and now we're talking about frickin' rounding errors, I feel. This has got to be some kind of rounding errors, floating point errors here. But 200.004999 fails. Whereas 1/200.004999 9, if I add another 9 to this one, now it passes. So how much do I trust this? I feel that this is... like, I'm just kind of analyzing floating point rounding errors. You got to teach me. We can trust 005. Hey, Leo Lectures. What's up, dude? Leo. What up, dude? Yeah, please do teach me some math, Leo. We got to do that again. 1/200 does work. Did I catch that eventually? I saw 1 over 200 fails above, but it passes below. Did I get that wrong? Yo, Divium, thank you again. Epsilon is 1. I know that. Above? No. Look. A 100 plus 1/200th quantity squared is... Oh, I wrote that wrong. I wrote this down wrong. My bad. This was 10,001.00025. My bad. I wrote it down wrong, but this one failed. Yeah. Yeah, that's my fault. So, just in case people are curious, what I did was I found that according to Steve Jobs, according to my Mac, this is 10,001.1234, like here, dot, 0, dot, 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 a bunch of zeros, and then 44. Right? So that is more than 1 away from 10,000. Whereas if I add one more 9 to this thing, now this is 10,000.999. How many 9s are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 9s in this one, and then in the previous one, there were 1, 2, 3, 4, 5, 6, 7, 8. There were 8 zeros. Okay, so this is the test. And we finally found a point, and that's good enough for me right now. So is this telling me that this needs to... Like, either I'm just analyzing floating point errors and something like 1 over 2c epsilon or some frickin' shit like that. Like, wouldn't it be like 1 over 2c times, like, epsilon over 2c or something? Or... Yo, Chui. The actual delta is some irrational, maybe. I was just curious, dude. I just wanted to see, like, I got a binary search, or I got a little test, and I was just curious at this point to take a break, really, and see how close to 200 do I need to be to 200.005. So it does sound like maybe it is some irrational, and it's not just something as simple as this. So how else could, because in this example, C is 100, and 1 over 200 is extremely similar, and epsilon was 1. So Bro, Chewy, thank you so much for joining as a channel member. Man, it really means a lot. Choi 820. Dude, thank you so much for joining as a Luna member. I'm going to write down your name on this problem that I'm currently working. Where is my pen? Choi 820. Dude, seriously, thank you so much for joining as a channel member. You're right there, dude. Appreciate you. Divium, I am starting, like, my number 3 playlist was on Andrews, but I didn't get that far, so I really don't want to promise too much for you about how much that playlist is going to help you. Like, don't try to treat those playlists as a way to work through a book. Just, like, yeah, don't try to treat those playlists as a way to work through a book. Like, how effective would this stream have been for learning epsilon delta? It's not a very good way to learn epsilon delta. Okay, so yeah, we did get stuck on a while loop, and I wanted to find it. We basically found it. So I think I can choose. Can I do something like this? Like, none of the examples in the book define delta in terms of C, but it seems reasonable to me. Like, we may just be hitting some kind of rounding errors because it's so close to 200. I want to see if ChatGPT can give me a hint on this one. In an epsilon delta proof, can I define delta in terms of epsilon and C? Yes, that's what I thought. C is fixed before you choose delta, so it may be a function of both. Yep, and it's using exactly... They're doing exactly this proof, too. The example that ChatGPT is giving me is this one. So, let's see. We get that. Restricting delta less than or equal to 1 gives x minus c, absolute value less than 1. So we get... Okay, wait. Oh, so we do... Okay, x plus c... Yep. So this is apparently like a standard example or something of this. Okay. So, many times through, we've been working from the scratch work like this. This is less than or equal to x plus c, x minus c, and this is less than or equal to x plus c, assuming delta is less than or equal to 1. Right, so we got here before, and then I had this idea before that this would be the same as x minus c plus 2c. I had that idea, and then this is less than or equal to x minus c plus 2 absolute value of c. Right? So we got to this point before. This is a triangle inequality. So if we defined delta as this, now we finally have a chain that ends up being less than or equal to epsilon. So the step that I'm doing right here is that delta I just chose was epsilon minus 3 absolute value of c. But I don't know that that is... I don't know if... That doesn't seem like a valid move because that's not guaranteed. That's not guaranteed to be greater than 0, right? So I don't think I'm allowed to do that one. Cool. I don't think that move works. I'll answer questions like once I'm done with this. I mean, by delta is, we could just choose delta to be epsilon minus 2 absolute value c, right? Yeah, plus 2 absolute value c. Yeah, what am I doing? Then now we just have epsilon. Okay, and now do we have a strict inequality anywhere along the way? X minus c should be strictly less than delta. It should be less than or equal to delta. Absolute value x minus c is strictly less than delta. And then finally, therefore, f of x minus L is less than epsilon. Cool. Yeah, there it is. Okay, so now we could restart the whole proof and say let epsilon be greater than 0 and choose delta equal to the minimum of 1 and epsilon minus 2 absolute value of c. Right? Then oh wait. No, shoot. Yeah, we still don't know that delta is greater than 0. Yeah, we still have the same problem that I was concerned about before. Yeah, like when c is 100, then this doesn't work. It doesn't make sense, or it fails. I'm just gonna read ChatGPT's answer. We got pretty damn close on this. We're so close. Yeah, it's nonsense, right? Yeah, it doesn't work. That doesn't work. It's a negative value. It's not greater than 0. Doesn't work. That doesn't work. I saw that too. Yeah, that doesn't work. All right, how does this go? We get x plus c All right, ChatGPT gives me x squared minus c squared is equal to absolute value of x minus c times absolute value of x plus c, restricting delta less than or equal to 1 gives x absolute value of x minus c less than 1. So absolute value of x plus c Oh, yes. Okay. Absolute value of x plus c. They are doing the same trick that I was thinking. X plus c minus 2c. Or wait, no. X minus c plus 2c. And then this, by triangle inequality, strictly less than 1 plus 2 absolute value C, right? Yeah, so we were super damn close. They're saying then choosing delta being the minimum of 1 and epsilon over 1 plus 2 absolute value C. Whoo boy. Works. Here, delta explicitly depends on both epsilon and C, and this is completely standard. The only thing delta cannot depend on is a particular value of x, since x is quantified after delta is chosen. Whew, this, man, I don't know. This feels like a hard problem for a thinking forward. Look at your graphical. I didn't follow your graphical explanation. I mean, I was thinking that same graphical explanation. I just don't see. I wasn't seeing like a way to get an algebraic. Like the graphical explanation was, from what I read, was like quite similar to what I was drawing here. And yeah, I really had a feeling that it wasn't going to be a square root. No, I wasn't going to find an algebraic solution here based on a graphical explanation any further. I had a feeling it wasn't going to be a square root thing, and it wasn't. So, yeah. So we're very close. This is extremely close to what I was, that I found with this process. So I should have just noticed that all of these were 2C, all of those. Yeah, I could have thought to just add 1, and then all of these would have, like, process would always work. That's kind of cool. I mean, like, we at least got to delta is extremely close to 1 over 2C, and it turns out that we can choose delta as 1 over 2C plus 1, and it would satisfy this. So I was damn close, and then somewhere along the way I thought, yeah, I believe that we can. See, look at this. I was so close. Epsilon over 2C. This is what I thought. This was like my hypothesis. We just were missing the fact that if I just added 1 to all of them, then that would satisfy all of these. Because, like, some of them failed. Like, I was trying to figure out what is that, like, more precise bit. And it would be something that depends on C, and it would be complicated, I think. Oh, your thing finds a tightest possible bound. Okay, so then your thing, you think that you can figure out what this is, right? You're saying that, because I think right now in my head that this is 2C plus some function of C, I believe. Yeah, it doesn't. I've already proven that it's not the tightest bound, right? Like, through this evidence that I thought was valuable, and it is valuable, I can see that it's not the tightest bound because some of these are tighter than 1 over 2c. It's 1 over 2c plus something. And I think that, like, I guess I don't care, right? What? And then this was the other thing that I was missing. I was missing that it should be absolute value of c. And it's where I paused and I was like, yeah, but like, what if c is negative and other things? So now I have some intuition a bit on sometimes I might be able to just add 1 and we would find it. Divium. Why did I choose this book? This book is excellent. It's both conceptual and applications based. So on the one end, we have Stewart, very popular. On the other hand, we have Spivak, very popular. Stewart is like applications or computations, calculations. No proofs. Spivak is all proofs, essentially. I really think Taalman is great because it gets both proofs and calculations. It's a great book. It's really nice. Let me read your questions, Divian. Where can you find math, like number theory? A book. Dude, I feel like I answered this earlier. I don't know, if you're asking about videos or something, like, eventually we will be adding more and more number theory in this series, but it's going to take a while, and you're going to learn some number theory in my abstract algebra, in the abstract algebra streams, which are going to begin in a couple weeks. I don't know. I really like Andrews as a nice number theory book. I like Andrews, and I like, for number theory, like, I can't cover every topic, every stream. There's too many subjects, and I'm never going to get anything done if I work all the topics. I need to stay focused and work one subject at a time or 3 subjects at a time. Andrews is a nice, cheap Dover book. I used Rosin for my undergrad book, and it's pretty good. It's pretty good. It's very friendly. Yeah, that's the name of it. I like Rosin for very friendly. Andrews is friendly and brief. Rosin is just, it's friendly with a lot of calculations, a lot of problems. If you want something harder, you could look at Ireland and Rosin, which is a different Rosin, which is confusing, but classical intro. Modern intro to classical number theory. Something like that. That one is hard, though. Harder. That should be your second number theory book. I don't know. Definitely books like Velleman. Like any kind of book that's like a intro to proofs book, like how to prove it. For number theory, you could do that, or you can always work problems from, every abstract algebra book is going to have a good amount of number theory in it. Galleon, I think, is going to be the undergrad book that we work, or Dummett and Foote. Abstract algebra books will work number theory, and we'll do some number theory, but it's gonna take a while. It's just, you know, we got to work systematically, slowly. Cool. I don't know Weissman. There's a lot of books out there. I'll do number theory eventually. I will eventually do number theory, but it's, you know, we're not going to focus on number theory for a while. I love number theory. I would like to focus on it, but I think that, I mean, I don't know. Like, Locke, do you have an opinion on this? Like, group theory or number theory to replace calculus for college math? I want to get more intro to proofs, and I think it's better to get some group theory out there. That's what my course, my intro to proofs course, was taught out of. It was intro to proofs in context of group theory. Multivariable calculus, nope, not for a while. Today was our farewell calculus final lecture, I think. Farewell calculus. Not in a while, because we are doing high school. Secondary school math is Basic Math by Lang. We are doing college math, and I think it's gonna be abstract algebra. And I think it's going to be Gallian. It might be Dumbit and Foot. And then we're going to do graduate school math with representation theory by Steinberg. If I add more books and more subjects than this, we're not going to be very effective in terms of developing pure math, proof writing skills, and having something cohesive and structured. It's really important to not jump around all over the place. Yeah, I think number theory is just not that necessary. Vob edits, you don't get a blue name because you're not a mod. We only have a couple of mods. There's just a few mods. And yeah, number theory is beautiful, but you can learn it. You can learn what you need in context of abstract algebra and others. So yeah, vote against multivariable calc because it's influenced by vector algebra. Yeah, that's a good point. Okay, y'all, I had a blast today. Super special thanks to everybody who's here, everybody who's, you know, supporting the channel, everybody who's just here chatting. Like, I appreciate you all very much. Arcane, what's up, man? It's been a while. I am definitely going to hold off on those others. I read your message before you retracted it. Someday we'll do other more analysis topics, but the thing is that that's not fun for me. Like, if I'm studying math for me, see you in the guitar stream in 5. I should do a guitar stream. Man, I should do a guitar stream. Vob edits, we are laughing. Am I in the guitar stream at the moment? What the hell? Am I also multi-streaming to the guitar stream? Wait. Am I in the guitar stream right now? Dude, are you serious? How did that happen? The hell? Am I guitar streaming? I'm not guitar streaming, am I? Okay. Confused. Or, yeah, you're laughing as in you're, like, making fun of me. Okay. Hey, Vav, you enjoyed episode 3. I'm happy to hear that, dude. I'm happy to hear that. Okay. I might guitar stream. I need to get better about a schedule and a flow to not neglect the guitar community. I really don't mean to be neglecting y'all. I'm just having so much fun studying math, and it's working. Came for the cat. Let me get the cat for everybody. Let me get the cat. Hello. Okay, so I don't know. She hasn't been as social today. It's surprising. Dude, do you? No worries. We should all be practicing guitar instead of watching. That's true. And y'all should be practicing math instead of watching too. No. Okay, she doesn't want to be here today. Sorry. Yeah, Arcane. For myself, I want to learn algebraic math primarily. I would like to learn algebra to the degree that I can start doing like algebraic topology at some point for myself, but it's going to be a while, I think. Right now, I just want to chill in representation theory for a while because I find it just like a really beautiful field. And then like a subject after representation theory that I've always wanted to hit would be Galois theory. Like once I feel ready to move on and I want like a new subject in the rotation, it would be rep theory, Galois theory, rep theory, Galois theory for a while. And yeah, like I just like algebra. Like after those, I'd be more interested in like learning type theory or theoretical computer science over topology. Like, at least for right now. But, or like algebraic geometry. I would like to learn a bit about algebraic geometry, but there's just so much. Like, I would love to learn it all, because I'm a freaking nerd. So, yeah. I just don't know, Skittles, what you meant by we are all laughing. I'm very, like, self-conscious about that right now. But, yeah, anyway, thank you, everybody. Yeah. I had a blast today, as always. Please do like and subscribe and share it with a friend. Y'all, if anybody wants to share the playlist, to the math, basic math videos, if anybody ever wants to share the playlist or get to the playlist, mathcanbeahobby.com. I've gotten that URL. I've gotten a few other URLs. Turns out I'm the first person to think, let me snag all the URLs with math, hobby math. So, hell yeah, dude. All it does is just redirect to the YouTube playlist. So, very shareable URL. Can just say out loud in convo. So, if you haven't seen my basic math videos yet, go to frickin' mathcanbeahobby.com. And we should get some bumper stickers or something. Hi, Luna. Hi, baby. Epic cat-tail content, yeah. She hasn't been as social as like, all over the place as I expected, but she will. Oh, the Lord. Okay. Thank you all. It's been a pleasure. I'm going to take a break and maybe stream some guitar this afternoon. This stream ran pretty long, so take care. Bye, everyone. Bye. And check out episode 3 if you haven't watched it already. It just went up last night, and it's all about practice of addition, I have like a few interesting little, I think that they're useful and interesting examples of like addition drills that you can build for yourself that are interesting, cool math problems, but they're also just a way to practice addition if you are rusty on addition. But they're pure math problems. You're not adding roller coasters and marbles and baseball hats together. So, yeah. Thanks for watching. Bye. Bye.